You know how to charge objects because you lived on this planet and you've rubbed your feet on the carpet. We need to go into a bit more detail. You need to be able to do diagrams showing me a neutral object, a net positive, and a net negative, and become aware of what the term net means. Describe the three methods of charging that we use, and using an electrostatic series to predict the charge deposited on two objects undergoing friction, and explain how certain natural phenomenon and technologies involve static electricity, and I want you to start using the letter Q for quantity. We start off knowing that atoms have a positive center or nucleus, and for every positive charge, there should be a negative charge called an electron. Therefore, an atom is normally neutral. It's not absent of charge, the charge balances. So if there are 8 charges here, 4 in the center, 4 opposites around, they add up to 0. So there is no net charge. Net means a sum or total after all the positive and negatives are canceled. It comes from the word neat, as in all tidied up. Net, as in a fishing net, is an unrelated word from the true English language, but in some ways you can kind of go net charge is what you got left over after you've run everything that cancels out through your fishing net. So if we remove negative charges, the object is net positive. If we add negatives, it's net negative. So in other words, if I look at each negative and positive here, they add up to 0. So there's a complete cancellation. If I take away one of the negatives, one of the positives no longer is neutralized, and we are left with a net positive. There are one other Latin letter I want you to get to know, Greek letter, is called sigma, which is the capital letter S. And in Greek, when this little sign goes away, you can see the symbol for sigma looks like the letter M on its side. The small letter for sigma is written this way. It looks like almost an upside down Q. And those two mean a total. They're used frequently. If you have an actual calculator, you may see those letters on it. So I want to add to your vocabulary the sigma for sum and Q for quantity. That's not too much to ask you. Let's take a look at these two. Or these three would be better. If you look at this one, every positive and negative cancels. So 6 positives, 6 negatives is 0. Here, there are a couple of positives that are not matched by a negative. So we have 2 positive left over. And on this one, you can see surplus negatives. So you get a net charge of -3. So in the electrostatic diagrams, we don't draw each individual atom. We just draw a representation of a neutral state having equal positive and negatives. We're not going to draw this 50 and 60 times inside a single drawing. So that's a slight difference. And these drawings predated the knowledge of the atom itself. So they had no idea how these charges were kicking around, but this concept emerged. Look at these 3 examples. Can you identify which of these is net negative, positive, or neutral? You can pause this if you're having any difficulty answering that. Now, what about showing only the net charge? Do I really want you on every single assignment to draw something that is net positive like this? No. What we'll often do, instead of drawing this, showing 4 positives and 2 negatives, we'll draw only what's left over. And that's really common in most of the textbook things. So we only show the net charge. So we say the whole object is positive. It could not possibly be made up of all protons only. It would blow the earth apart if that happened. So we only tend to show the surplus. So, on any given thing like the head of a pin, if you charge it on a rug, there might be only a couple of quintillion extra electrons. It's nothing at all. Now we're going to look at the charging methods. Okay, but I'm going to pause the slideshow here because I want to break it down into several groups because it's a really long lesson. But when we're done, it sums up to very little actual learning, but it's a long story to get there.